Our second problem is about fun-size Snickers bars, and they're supposed to weigh 20 grams. Because the penalty for selling candy bars under their advertised weight is severe, the manufacturer calibrates the machine so the mean weight is 20.1 grams. The quality control engineer at M&M Mars, the Snickers manufacturer, is concerned about the calibration. So he obtains a random sample of 11 candy bars, weighs them, and obtains the data shown in the table we have below. Should the machine be shut down and recalibrated? Note, shutting down the plant is very expensive, so the the quality control engineer decides to conduct the test at the alpha equals 0.01 level of significance. Is it a simple random sample? Yes. We're told that he obtained a random sample. Are there outliers, and is the population normally distributed, or is n large enough to assume? Well, n is only 11. So we can't assume. So what we need to do is check for outliers and the box plot. So in order to do that, we're going to get our calculator, and you should pause the video and go to Stat, Edit, and put your data in, which I've already done. Once you've done that, hit second mode to quit. Then hit second and Y equals right above it. Hit enter on the first option. If yours is turned off, just arrow over so that it's flashing on and make sure you hit enter so that it's selected. The type of plot we want is the one that shows the box plot looking thing with possible outliers. So it's this one on the bottom left. And to get to it, you just keep pushing the right arrow till it's highlighted. Make sure you hit enter again so it's selected. Your X list should be L1 where you put your data, and your frequency should be 1. Doesn't matter what the mark looks like. Then we're going to hit second mode again to get out of there. And to graph it, we want to hit zoom and then go down to number 9, zoom stat. And when we hit enter, it generates a nice little box plot for us. Looking at this box plot, the right whisker is longer, so that means that this looks like it's skewed right. There are no outliers because if there were, there would be some points past the ends of our whiskers, and there are not. So we can say, based on that, that there are no outliers and that the distribution is slightly skewed right. And it doesn't really matter which direction it's skewed, but it's slightly skewed. And since it's only slightly skewed, we can still use it. And by it, I mean the hypothesis test. Is the sample size less than 5% of the population? Well, think about how many, probably thousands of Snickers bars they make a day. So I would definitely say yes, 11 Snickers bars is much less than 5% of the population. Let's go state our hypothesis. So we want to test whether or not the average weight is what the machine is calibrated to, which is 20.1. And we want to know whether or not the calibration is different from 20.1, because we don't want the candy bars to weigh too much, because then we're losing money. But if they weigh too little, then we're going to get fined and we're losing money again. So if we select the significance level, the problem told us alpha is 0.01. So if we find the test statistic and p-value, this time we put it on data when we do the t-test. And so it's going to ask us for our list where our data is. For me, that's L1. And it's going to ask us for a frequency list. Or maybe it says frequency. Let's check. So let's do our test now. We can hit clear to get rid of the graph. We're going to go to stat, over to tests, pick number 2, the t-test, and we want to put it on data. So highlight it and then make sure you click enter so it stays that way. mu0 is our 20.1, our hypothesized mean. My data is in L1. Frequency, we're always going to have 1 for this. And then we said we wanted our alternative hypothesis to be not equal. So we hit enter and go to calculate. Our test statistic is 1.04 and our p-value is 0.3236. So we can write that down. I'm sorry, let me go back and fix this frequency. Frequency should be 1. So our test statistic T0 is 1.04 and our p-value is approximately 0.3226 if we round to 4 decimal places. So state the decision. P-value is definitely bigger than alpha because the p-value is 0.3226 and alpha is 0.01. So that means we do not reject the null hypothesis. So what is our conclusion? Our conclusion is there is not sufficient evidence at the alpha equals 0.01 significance level to conclude the Snickers bars have a mean weight different from 20.1 grams. So that means the machine does not need to be recalibrated. In the next video, we'll talk about the difference between statistical and practical significance.